Thank you very much, Cindy. Welcome, everyone. I hope you're very excited to be here. This is an amazing building. I think it's brand new and it's incredible. I think it's a sign of things to come. You know, at Wizeline, and we love to support Cindy and StartupGDL and all the things she's doing because we really believe this is a very critical time in history, and especially for this place, for Jalisco and Guadalajara and Zapopan. Because so many things are changing, but those things are changing in a way that gives you a tremendous amount of opportunity. And the way that technology affords that opportunity, a unique opportunity for this area, is that you can be at the cutting edge. You don't have to work your way up. You know, sometimes when we think about technology, you know, those of you who maybe played Civilizations, it's like a ladder, right? And you got to work your way up to the top. But this time in history allows us to just skip right to the top for things like artificial intelligence and computer vision and machine learning and all of that stuff. It's all available to us right now. And what it can do is unlock the ability for us to make this a place where we build the very best products, the very best ideas, all of the things in the world that you find interesting, you can jump to the front and make meaningful contributions. And I think that's really the message that I'm taking away from tonight. So let me talk about our two speakers. We have Joe Smarr, who's an old friend of a lot of us, went to Stanford, comes from kind of, and he didn't tell me to say this, probably would prefer I not, comes from a kind of royalty in technology. His father was an early member of the NCSA, which is where the browser, and you might say that the internet as you know it, came from. He now works at Google and obviously has access to a lot of the most interesting things that are going on, and he's brought this with his friend Daniel together in a very interesting way with technology. Now, Daniel has worked also in the Silicon Valley for years and years and years, but has, over the past few years, let art become kind of his focus, first in photography, and now with this deep dream, kind of tied things together in a way that, as you've seen if you come up and look, is extraordinarily interesting. It's very contemporary, and like I said, it shows the power of making technology work for people, technology create new opportunities for creativity. So without further ado, I would like you all to recognize that someone has flown all the way down here doing the first international exhibit of this incredible work, and give him a gigantic round of applause. Daniel, come and take it away. Hit the mute button.
Hi everyone. Can you hear me okay? Ah, here we go. Hey, thanks for coming out tonight. It's really great to be here in the awesome city of Guadalajara. Joseph and I are both so honored and grateful to be able to do this in this vibrant city where we see both an incredible art community and a tech community, and that's really what this whole project is about. So what I'm going to do for the next 20 minutes or so is kind of give you a little class and teach you all my secrets, how I've done what I've done, the process I've gone through, and I hope to make it a lot of fun for you as well. Let's talk about special places. What I mean by that are places, precise locations in our world where something very powerful happens. And I'm not just talking about landscapes, but also cityscapes. How many of you have noticed that in certain places at certain times, the scene before you goes beyond a mere sight and becomes something you feel in your body? Have you had that experience? Whenever I find myself in the midst of such scenes, it's like a bell rings. It stops me dead in my tracks. What starts as a visual perception immediately becomes a visceral experience, one that I feel right in the middle of my chest. And when a scene is powerful enough to do that, I find myself waxing philosophical, asking questions like, wow, I wonder how a butterfly would see this scene. And what would I see if my vision was many times sharper? What's real anyway? Now, I'm sure many of you have experienced something like this too in the presence of special places, this powerful connection that is quickly formed between your eyes, your body, and your mind. And if you're like me and many other people in the history of mankind, I suspect, you then find yourself desperately wanting to bottle that experience and do it with such fidelity that when you share it with others later, they feel the same thing that you felt. Also, like me, you may have found it very hard to do that with traditional photography. This drove me crazy. So it had me wondering, what constitutes this phenomenon? And how can it be communicated? Is it even possible? The answer is yes, and I'm going to show you how. It turns out we have an existence proof. The great American painters of the Hudson River School in the early 1800s and the European Romanticists before them achieved this effect. They painted highly detailed scenes, some of which were 10 feet wide or more, with great emotional impact. Painters like Thomas Cole, who's considered the founder of the Hudson River School, and his incredibly skilled friend Asher B. Durand, and many others along with them created these incredible, powerful works like these. Cole's protege, Frederick Edwin Church, was hugely successful at doing this. Let's talk about this painting for a minute. It's called The Heart of the Andes. When this 5-foot high by 10-foot wide masterpiece debuted in 1859, it was an absolute sensation. It was first exhibited in New York City as a single painting exhibit. In 4 weeks, more than 12,000 people paid admission to view just this painting. The painting was widely acclaimed. Poetry was written about it. A composer dedicated a piece to it. Mark Twain wrote about it. The following quote proves my point, that it is indeed possible to capture and convey the power of a special place. A contemporary witness wrote, "Women felt faint. Both men and women succumbed to the dizzying combination of terror and vertigo that they recognized as the sublime. Many of them will later describe a sensation of becoming immersed in or absorbed by this painting, whose dimensions, presentation, and subject matter speak of the divine power of nature." By the way, this painting now hangs in the Metropolitan Museum of New York in New York City. Next time you're in New York, you really should spend some time looking at this in person. So before I get into exactly how Frederick Church and his contemporaries did what they did, I want to mention one more painter who was very influential to me, Maxfield Parrish. Parrish came along much later, in fact, well after the art world moved beyond representational landscapes, but he brought a level of vibrancy and lucidity to his landscape paintings that I absolutely love and that hadn't been seen before. I don't have time to explain how he did what he did, but one thing I can relate to is that he did it by tinkering and experimenting with both old and new approaches to his medium. Okay, now let's get into the how. I'll use my own work to illustrate this, starting with this scene that I captured at Nymph Lake in Rocky Mountain National Park, Colorado. In healthcare design, there's been a lot of research around what is known as healing art. Designers and administrators wanted to know what kind of art, if any, can reliably make patients feel better. Well, it turns out there's only one kind that does, and it's representational landscape scenes. Healthcare design consultant Barbara Lyons Stewart wrote, "Every evidence-based design study I found has proven that only viewing representational landscape scenes measurably decreases heart rate, blood pressure, and pain while improving mood." Some people refer to this effect as the pastoral experience, but when you dig into this, you find out the pastoral experience is not achieved by subject matter alone. It actually requires 4 things: subject matter, composition, technique, and presentation. Let's briefly consider one at a time, starting with subject matter. The pastoral experience occurs with scenes featuring things like green fields. It also includes water scenes, hill and country scenes, sweeping views, coastal views, marshes, farmland, groves of trees, beautiful vistas, sunrises, and sunsets. But like I said, it's not just about subject matter, it's also about composition. In a guide to evidence-based art, the author specifically mentioned immersion, compatibility, and extent. Immersion is best achieved with the presence of strong foreground elements like the trees you see here on either side, and/or wide fields of view. Compatibility refers to the resonance between the natural setting and human inclinations. Essentially, man-made elements subconsciously make the viewer feel safe. They sense that other people are thriving there. And then there's extent, which is characterized by scenes of distant wilderness, trails and paths leading to idyllic destinations, and a sense of being connected to a larger world. This quote really sums it up. The most fundamental feature of a restorative place is that people have to feel that they can move into those spaces and have a wonderful experience. Okay, now let's talk about technique. How do we achieve the pastoral effect with a digital camera? It starts with something I call XYZ photography. You'll see why I call it that in just a minute. First, let me tell you about my gear. The Sony RX1 was the first full-frame sensor compact camera when it was released 3.5 years ago. It has everything I need and nothing more. An incredibly small form factor, a beautiful fixed 35mm Carl Zeiss lens, and the new version has a whopping 42.4 megapixel sensor. With a small camera like this one, I can get away with a fairly compact tripod, on top of which is a similarly compact but very important contraption called a panoramic tripod head, which gives me a precise way to capture overlapping views of the scene I'm shooting. And that's all I need. With this compact setup, I then capture multiple views horizontally, let's call that X, multiple views vertically, let's call that Y, and multiple exposures deep from dark to light, let's call that Z. It's not really deep, it's not really depth, but I'm also a marketing guy, so sometimes we have to take some liberties. On average, it takes me about a minute to capture the entire scene. I then use 3 different commercial software packages to merge this cubic array of photos into a coherent scene. I blend the multiple exposures from front to back with Aurora HDR. I stitch together the multiple views with AutoPano Pro, and then I crop and sweeten the image with Photoshop. And what I mean by sweeten is all I really do is adjust the tonal range just a little bit to take the haze out. Now, I'm calling these interim results because you may have noticed I haven't yet started talking about the exciting artificial intelligence software, Deep Dream, that we'll be talking about, which I started using this year, but be patient, we're almost there. With the technique of XYZ photography, you end up with a scene that is more immersive due to the wide angles, the X and the Y, a scene that is more vivid due to the high dynamic range, the Z, and a scene that is much higher fidelity, containing up to 200 times as many pixels as HDTV, and anywhere from 10 to 40 times as many pixels, as you can see here, as you'll get with the Pro DSLR camera. What you're seeing here is an unretouched photo of a 4-foot high by 8-foot wide light box that shows the kind of detail and richness we're talking about. So I put this graphic together to illustrate the XYZ difference. The inset photo you see on the right is what you get with a high-end camera capturing a single exposure with a 35mm lens. You can see that the XYZ method yields an image that is much more immersive, more vibrant, and much higher resolution. Finally, we must consider presentation. To be most impactful, these scenes should be printed, in my opinion, no less than 8 feet wide, and they should be backlit. We are creatures of light. We're drawn to light. That's why I've been so focused on light boxes these last few years. A big bonus about light boxes is this: they are containers. It's very easy to replace this print and put a new one in there and keep things fresh and interesting. All right, and now for something completely different. In the last 5 years or so, there's been an incredible revolution in artificial intelligence and deep learning thanks to rapid advances in both hardware and software. I'll let Joseph speak more in depth about this after me, but in July 2015, Google released a bit of open source software called Deep Dream, which became a viral sensation. Deep Dream was originally created to help Google researchers understand how their own software was working. That's how complex this stuff has become. What the researchers found when they applied Deep Dream to image recognition software was that the machine was essentially hallucinating as it tried to figure out what it was seeing. When they saw these results, they thought it would be cool to see what people did with this, so they released the software, and the internet went crazy. So I'm curious, how many of you, when that happened, heard about Deep Dream and maybe even played with it yourself? Okay, a few. Well, per these headlines, what most people did with this was they turned their family photos into psychedelic nightmares. Now, as you can see here, some of these results were quite intriguing. I, however, sensed an opportunity to do something a bit more, shall we say, subtle. So I tried applying Deep Dream with a light touch to some low-resolution previews of my landscape images. The results were very well received, and they really excited me because I realized this gave me an opportunity to add a level of expressiveness to my landscapes that could be very rich. And just like the art world in the early 1800s began moving to more expressive, individualized modes of painting landscapes, starting with the proto-impressionism of J.M.W. Turner, and later the true impressionism seen, for example, in the pointillism of Seurat, and the unique styles of folks like Cézanne and Monet, I thought I too might be able to take my landscapes in a new direction. Alas, Deep Dream as released was simply not designed to operate successfully on multi-hundred megapixel images. It would just crash. I was completely stuck. And that's when I thought of my friend, Joseph Smarr. Oh, I thought, Joseph would know how to fix this. It'll probably be easy for him. The fact that he had no prior experience in graphic software, is busy with 2 small children, and a full-time challenging job at Google didn't stop me from asking. Much to my delight and amazement, Joseph eventually said yes. And later, when he asked his good friend Chris Lamb to help him, Chris said yes too. Lucky, lucky me. Well, it wasn't easy for Joseph and Chris. It took a lot of work to keep Deep Dream from crashing on my images. When I'm done, Joseph will share more details about the challenges they faced and how they overcame them. But after months of hacking on nights and weekends, by November last year, they finally got it working using a monster compute server with 4 graphics processing units up on the Amazon cloud. My job would then be to learn how to tune the many parameters of Deep Dream for the best results on my landscape images. So a couple months later, in January this year, they handed me this interface. You just have to love the wording of this interface. Start dream, new dream, dreaming, dreaming success. Now here's a button down there though you don't ever want to touch. Cancel dream. Take it from me, don't ever cancel your dreams. When we first started to get results, I was delighted to see the following happen. I wasn't sure it would, I thought it might, but it's something I call the museum experience. One thing I always enjoyed when visiting museums is this far versus near dichotomy. When you enter a gallery space, perhaps you see on the opposite wall this large, gorgeous landscape, almost photographic perhaps, even though it's been painted, say. But when you get right up close to it, you see all the brushstrokes and perhaps some hidden details. It's like having two entirely different experiences. So here's the funny thing about this. How many of you have heard about the Google Art Camera? Anyone? This is, it's a really cool project. The Google Art Camera is an incredible special purpose robotic gigapixel camera designed to help document and preserve in great detail the world's art treasures. One of the engineers at the Google Cultural Institute, Ben St. John, wrote the following in a blog post about this project. He wrote, "So much of the beauty and power of art lives in the details. As you step back from the brushstrokes, you wonder how it all comes together." Now, you may find yourself wondering the same thing when you look at our dreamscapes. How does it all come together? And I have to say, I find it somewhat ironic that one research lab at Google has developed advanced technology, the Google Art Camera, to pull details out of existing artworks, and another research lab at Google has developed advanced technology, Deep Dream, that can be used to put details into new artworks. Same effect either way. Besides the expressiveness that Deep Dream lent to my work, another thing that excited me when I saw the results was the opportunity to participate in another art tradition, that of camouflage and dual meaning, such as you find in the works of Arcimboldo back in the Renaissance, who painted portraits composed entirely of fruits and vegetables and flowers, etc. And in the late 1800s and early 1900s, Abbot Thayer, whose interest in protective coloration in nature ultimately led to the use of military camouflage in World War I, and of course the great Salvador Dali, whose works are filled with illusion and multiple meanings. This then brings us to presenting dreamscapes. With this kind of detail, in the digital realm, these works are essentially in prison. Yes, you can zoom into them online, but something fundamentally better happens to a scene like this when you can walk right up to it and see all these details while maintaining the rest of the image in your peripheral vision. That's one reason why I chose this large format medium. And as I said earlier, I'm all about backlighting. I should also point out that the rich parameter space of Deep Dream, there's so many ways I can change it. It enables me to commit to digital originals, which means never printing the exact same image twice. Another option for viewing dreamscapes is with large video walls. Actually, the first opportunity Joseph and I ever had to see our dreamscapes at scale was actually on the Vroom display down at the Cal IT2 facility at UC San Diego, which is also known as the Qualcomm Institute, which is headed up by his father, the illustrious Dr. Larry Smarr, who Matt mentioned earlier. Boy, was this a great day. Yeah, we looked at our entire collection of dreamscapes on this giant video wall. It was a great experience, even if at 66 megapixels, which is a lot for video, a display this powerful could only deliver a fraction of the available pixels in our dreamscapes, but it was a start. So we were pretty happy to see these. A lot of people ask me about viewing dreamscapes in virtual reality. As you can see here, one of the benefits of doing this is that the VR gear can be very stylish. all right? Seriously though, I've had the good fortune of viewing my Dreamscapes in the VR labs at both Facebook and Google. And interestingly, they each took very different approaches to the presentation and interface. I can't give you the details of that, but one common problem they both had to solve was how to deliver the pixels efficiently so the system only had to provide full resolution as the pixels were needed based on where you looked and how much you zoomed in. So just a quick observation I want to make about all this, and perhaps about technology in general. If you look at the different technologies and methods employed to capture and convey the power of a special place, you'll find that each time a paradigm shift occurs, like the transition from painting to photography, or from photography to VR, there's a lot of initial excitement and anxiety. I'm sure landscape painters in the early 1800s felt pretty threatened when at the top of their game, this device comes along that can capture the actual photons of the scene that's being represented here. But the truth is, photography was at first a big step down, right? You didn't have the color, the resolution wasn't there, you couldn't make huge prints, right? But it steadily improved, and you had folks like Ansel Adams producing majestic black and white landscape images in the first half of the 20th century. And in the mid-1900s, Elliot Porter, whose intimate landscapes did much to boost the acceptance of color photography as an artistic medium. And in the late 20th century, Peter Lick, using panoramic film cameras, created works that, at least in some respects, surpassed those of the great representational landscape painters. Well, I think a similar thing is happening now with the advent of virtual reality. Again, a lot of excitement, but a bit of a step down in quality and impact from what I've seen, with lots of room for improvement and plenty of problems to solve. That should be of interest to a lot of you tech guys in here. There's lots of work to do. But that will happen, and I, for one, don't feel threatened by this. Quite the opposite. I'm excited to work with folks like Joseph and Chris to help make that happen as we move ahead. So back to Dreamscapes. Just for fun, I'd like to wrap things up by showing you a handful of other Dreamscapes in my collection, along with a representative 1 foot square detail if these images were printed 8 feet high, just like that one. Starting with this was captured at the aptly named Dream Lake in Rocky Mountain National Park, Colorado. We'll take a look at this area down here in the red box. There are a lot of different styles that I can use with Deep Dream. There's at least 84 different sort of macro styles, each one of which has several parameters that I can tweak. So what I'm doing here is just showing you a little bit of the range of opportunity that it gives me as an artist. I was lucky to catch this rainbow here in October last year in the hometown in northern Italy where my father's parents were born and raised. Let's take a look at this cottage on the left here. This is Ithaca Falls on the Cornell University campus in upstate New York, where I went to college in the late 70s and early 80s. And I can tell you there were a few times back then when it looked just like that to me. Here is Echo Canyon in Zion National Park in Utah. I chose this streaming style because it seems so compatible with the rock formations. It almost looks as if the Native Americans carved every square inch of the canyon. This one is a lot of fun. This is the Japanese Tea Garden in Golden Gate Park, San Francisco. Look at what the dreaming did to these people back here in the red and yellow jackets. Can you see them in that red square? There's a little red and yellow. Those are people with red and yellow jackets on. Turned them into birds for those that can't see it in the back. And they're not just pictures of birds that Deep Dream took from someone's photos and pasted them in. They're literally the idea that Deep Dream has in its brain about what a bird is. It's pretty cool. So I'd like to end by coming back to my original aspirations. What I hope I've been able to do with the help of my ingenious engineering collaborators, Joseph Smarr and Chris Lamb, and the tireless efforts of my new best friend, Deep Dream, is to share with you my experiences in these special places. I want to project their power and beauty through your eyes in such a way that you feel it in your body and it inspires your dreams. Thank you. This is still recording.
All right, that was awesome. Thank you, Dan.
Thank you.
It's the first time I've seen Dan give that sort of full talk with all the art history and tech mixed together. I thought that was pretty interesting. So I thought I would complement that by just sort of geeking out with you guys for a few minutes on some of how we made this possible. And there's really kind of 3 points, I guess, that I wanted to leave you with, just to tell you up front. One is that this was actually something you guys could totally do. I mean, I didn't have any special background or training for this, and as you'll see as I talk you through it a little bit, a lot of it just comes from that normal kind of engineering entrepreneurial hustle of like finding a roadblock and overcoming it and kind of keeping going. And so it may seem kind of like a big fantastical thing. It certainly does to me now, seeing it printed so large and all of that. But the actual effort of going into it and the process of going into it was not unlike lots of little hacking side projects that I'm sure you guys have all done. So I think that's kind of an empowering message. The second thing is, what was really surprising for me about working on this project was I originally just did it because it seemed like kind of a fun challenge, right? It's like, oh, let's see how much we can scale this thing up and if we can really make it work. And it was a fun engineering challenge. I mean, like any engineering, it was sort of frustrating at times, but ultimately pretty satisfying. But what surprised me was how much it meant to me at the end to have used my engineering ability not just to build another useful gadget or to help somebody get their work done a little bit faster, but to actually use it in the service of artistic creative expression. That's not something I really had thought of before as like an important priority for me to work on. But it's been amazing to watch, sort of not only personally gratifying to see how much more Dan did with the software than we originally thought was possible, but also just how much it's impacted everyone that we've shared it with and how much it's gotten them thinking, gotten them inspired. And so that's just sort of something for you guys to think about when you think about what type of projects you want to work on. It hadn't occurred to me until I did this that would be something that would be worthwhile, and now I'm totally excited to do more things like that. And the third is, one of the things that I find most compelling about this work is, and I didn't set out to do this, but it's just sort of, I think it sort of happened by naturally, is, there's all this anxiety going on right now in the press and in public discourse about the future of AI and what does AI mean for the future of work and are the robots going to replace us and that sort of thing, right? And in many ways, this is a very, very concrete manifestation of that conundrum. I mean, Dan wanted to make a certain kind of picture. He couldn't really do it on his own. I mean, you could imagine what it would take to paint something like that by hand, right? It would take you the rest of your life. And so he turned to an AI to help him have a superpower. And it granted him that superpower, right? I mean, he built something amazing that people love that has transformed his career and so forth because he had this AI working with him. But it also meant sort of giving up a fair amount of control and even understanding of what the AI is doing. I mean, I wrote the code and I still don't really understand why it's doing what it's doing. I can explain the code behind it, but it's ultimately emergent, right? There's a trained model that's been trained on lots and lots of different kinds of images. If we used a different neural net that had been trained on different images, it would produce different hallucinations. And then the fact that it's iterating, over and over and over again over so many million pixels, we do something like 90 quadrillion floating point operations every time we create one of these images, right? There's just no way to really understand what it is that it learned and what it is that it's applying. And it's ironic because the whole point of Deep Dream originally was as a diagnostic tool to help understand what this otherwise fairly opaque, weight matrix the neural net had figured out. But it's still kind of a mystery, and it's sort of I think that's a really good analogy for, I think, what's going to happen with us in computers in the future. We're going to be more and more powerful, and we're going to be operating a little bit outside our comfort zone in terms of control and understanding. Like if somebody said, Dan, I love it, but I want you to put the swirly eye over here instead. Like, we can't do that. We don't know how to tell the computer to do that, right? We can tweak the parameters we know how to tweak, but we don't have that level of direct control. And so it's interesting, right? I mean, it's a little bit uncomfortable, but it's also very exciting. And I think it's a fundamentally optimistic message, right? Because it's not like the computer took his art job at the end of the day, right? It's not going off and creating artwork by itself. And in fact, it's ultimately been a real boon, right? But it's just kind of a different way of working. And I think it's something you guys should all maybe think about, which is that, you know, what our future is going to be like as well. Okay, so just a little bit on the details of how we made this work. So fundamentally, you know, Google and others have built these deep neural nets, which you start by taking an array of pixels and you feed it into the bottom layer of the network. And then each layer of the network is essentially learning a pattern of the inputs. So you can think of the first layer as sort of looking for patterns of colors or lines or so forth. And then the next layer above that looks for patterns in the patterns of color and lines and so forth. And the next layer is learning patterns on that. And so the more deeper you get, the deep learning comes from the fact that, you know, these days they're building these neural nets with a lot more layers than they used to. And they can do that because they have more compute power and more data, so they can actually train these much more complicated networks. Interestingly, the core sort of backpropagation and other, you know, math and algorithms behind the neural nets we had in the 1980s. So it's not like there's necessarily been some key breakthrough on the fundamental science of it. There's been a lot of engineering progress in terms of how to actually scale these things up. And just like the human brain is basically made of the same stuff as a mouse brain, but the scale starts to create, you know, a qualitative difference after a while. You've seen the same thing with deep learning. So interestingly, the way, if you use like Google Photos or something, and you search for show me my photos of dogs or show me my photos of sunsets, it's using basically this same neural net, you know, feeding the pixels in and at the end trying to learn the different categories of image. And the way it actually works is it takes your image, which might be several megapixels, and it scales it down to a pretty small size so that it can actually, you know, give each pixel to a neuron and feed it through the network, and it's not too expensive. That's great for recognition, but it's not great if you want to dream on a giant image and not lose all the details, because obviously if you just scaled the image down and then scaled it back up, you would lose all of that, right? So we realized pretty early on we were going to have to do something a little bit unique. In addition, the actual computation of the neural network is done on GPUs like these NVIDIA cards, because it really is about 10 times faster than doing it just on the CPU. But the way the GPUs work, they have a fixed amount of memory that you have to load the data into, and then it can run the computations and then spit out the result. And you just can't put more than that in there. And obviously, an image like this, which, you know, even at a few hundred megapixels, the JPEG is maybe only a few hundred megabytes, but that's very compressed. And if you want to actually operate on it with a neural network, what you have to do, of course, is uncompress it so that each pixel is represented by, you know, a 32-bit RRG and B value. And so it's sort of like an order of magnitude more memory to keep one of these entire things in memory. And you can't just put the entire thing on the GPU. And so we sort of figured we had to do some sort of tiling. But of course, you don't want to just do it in a linear way, because then you'd see these big seams, and that wouldn't be very interesting. And so long story short, what we ended up doing, and this was credit to some people inside of Google on the original Deep Dream team who helped us think this through, because I sort of posted those initial low-res images internally and just said, hey, my friend kind of talked me into working on this thing, but I have no idea what I'm doing. You know, do you have any suggestions? It seems like we're going to have to do this or that or the other. And, you know, and that's a lesson for you guys too, of like, I didn't necessarily know in advance that this would even be possible, let alone exactly what to do. But I figured, you know, hey, I'm a smart engineer, I'll roll up my sleeves and, you know, take it one step at a time. And that's really all it takes to get started on a project like this. And I was surprised, as I'm sure you guys have been in the past, of how many people were willing to kind of help pitch in and, you know, remove a roadblock here or give an idea there. And so what ends up working really well is you break the image down into little tiles, but you randomly jitter the tiles each time. So you sort of wrap the image around top to bottom, left to right. And that way, if you keep doing that over and over again, you've eventually kind of dreamed on the whole image, but in a way where you don't ever see the seams. And we also do this at multiple scales. So we scale the image down quite a bit, not all the way down, dream on that, then scale it back up, dream on the result, scale it up, dream on the result, and so forth. So you get this sort of blend of scales as well as difference. And that's why if you go up really close to it, you really can't tell you know, where one tile ended and the other began, because ultimately it has sort of dreamed on the entire image. It's just done a little bit at a time. And that's also why you get this amazing near versus far thing, because remember, this is, you know, several 100,000 megapixels, 700, right? Yeah, several
240 megapixels.
240 megapixels, right? I'm losing my orders of magnitude. So even the point being, it's probably several hundred dots per inch, even printed at this scale. And so even a tile of, you know, 1,000 pixels by 1,000 pixels is a very small piece of the image. And so that's the level of scale at which the dreaming is happening, right? And so if you skip way back, you basically don't even see it at all. And the other thing, which I don't fully understand, but I think is one of the most amazing things about this, is all of the fine contours and structure of the edges of features are incredibly well preserved. So even though there's a ton of swirling and distortion happening, you can read text, you can see people, it's quite amazing. And I believe that has to do with the fact that not only are the individual tiles not that big, but some of the very first things that the network is doing is looking for edges and so forth, and so that sort of ends up getting preserved through the higher level patterns. Just a quick bit about how we actually produce the hallucinations. So the way Deep Dream works, they were trying to figure out what these intermediate layers had learned. Because you put pixels in, you get a bunch of weight matrices in the middle that don't make any sense to you, and at the end it says 99% dog, right? But when it gets it wrong, how do you know what to fix? And so they had this idea, well, what if we dreamed up to a middle layer where it's learned some fairly abstract pattern, but it's not yet dog? And then what if we asked the network, okay, given the weights you've already been trained on, if I'd given you slightly different pixels, what would you have seen, how would you have seen the thing that you saw more vividly? So maybe it starts to see an eye, or maybe it starts to see a face or something, and you sort of say, well, how could I have tweaked this image a little bit so that you would have seen it even more? And what you're trying to do is basically figure out what is it that that thing learned to recognize. What you fed it in wasn't the perfect eyeball or face or whatever, but it had learned something like that, and so by tweaking the image, you can sort of figure out what it had learned. And they actually learned a lot of interesting things this way. For example, when they realized they were trying to learn how to classify a hammer, that the image that they had, when they dreamed it out, it always had an arm attached to it. And obviously we know that hammers don't need to have arms attached, but when they looked at the library of images they'd given to train the model, every one of them, it didn't just have a hammer sitting on a table, it had some guy with a hammer, right? And so how did the network know that hammers don't have hands attached to them? So they actually did learn some useful things like that allowed them to change their training data and so forth. But as a byproduct of that, when you amplify the image to see what happened, the pixels themselves get changed, and so you get these sort of hallucinations. They sort of released this internally at Google just as sort of like, haha, isn't this funny? Like my tools spit out these weird things. And a bunch of people internally started playing with it and going like, wow, that's really cool. And they wanted to play with it with their own images and so forth. And all the code in Google is open to everybody, and so it was very easy to do. And I think peer pressure kind of grew to the point of like, wow, we should really open this up externally and let other people play with it. And that's where all the psychedelic nightmares came from. And so the last thing I'll say, and then we'll stop and maybe take some Q&A in case you guys want to explore any more of this later. I don't want to geek out too much, or do I? Is running this on Amazon. So originally we thought, oh man, we're going to have to convince Dan to buy some very expensive machine with lots of RAM and GPUs, and we don't even know how big it's going to be, and we don't really know if he's going to do this or not. So it seems like a big pain to put down $10,000 or something just to figure it out. So let's at least start with Amazon EC2, and we can get a instance. We can figure out how much RAM we need and so forth. And then once we get it working, we'll figure out how to buy a box. And it was a good thing because like I mentioned, it wasn't just about getting it to fit on the GPU, but we had to make it not take up all the RAM in the world. And a lot of the actual labor that went into making this work was not just the tiling work, but also just very careful memory profiling of each step of the algorithm and each step of the libraries we're using to avoid as many memory copies as possible. Because it's one thing to have inflated this whole thing into multiple gigabytes of RAM per image, but then you just don't want to have those lazy array copies and things that you all know it's very easy to get into code, and then all of a sudden your thing crashes. And so we just spent a lot of time stepping through and waiting to see what happened, and then figuring out if there was some clever way to avoid copying that particular step, and including changing some of the libraries. That's why it's so nice. This is all in Python, and so many of the open source libraries that for numeric processing and image processing and neural networks and all that are open source themselves. And so it was we could kind of get in there and tweak whatever we needed to. And again, it wasn't like I needed a PhD in computer graphics to figure it out. It was this sort of normal engineering stuff of step through the method. Okay, by here it had this much memory, and by here it had crashed. Let's figure out what happened in between, and so forth. And after a while, you turn the crank, and it got to the point where it was working. And at that point, we said, gee, why shouldn't we just keep using this Amazon instance? Because after all, even though we had to use literally the beefiest GPU instance available, which would have cost probably tens of thousands of dollars to build ourselves, the cost to run it on Amazon was like $2.50 an hour. And so it was like, okay, we could do a fair amount of dreaming there before we hit break even, right? And so that's what we're doing today. And it was great because we could just point Dan at an instance, and we built this little web UI you saw in front of it, which is just a very simple little Django Python web server, and then we use a little celery queue to actually enqueue and do the work so that he can put in the parameters and say start dreaming, and then it will go off asynchronously and start working on it, and you don't have to wait 10 hours for the page to load. It just sends progress back. And then when the image is done, it just saves it to disk and he can download it. So my point is it was pretty simple stuff, and it didn't require a lot of heavy-duty engineering, and the goal was just enough to let him go to town. And we actually, when we first got it working, I'm sure whenever you first get your code working, it's kind of like, okay, don't touch it, I'm afraid it's going to fall over, right? It just barely got it working. But he went off for a week and just went crazy trying different images and different parameters and everything, and you know, it ended up being very robust. And so it was really gratifying because again, once you build it once, you can use it as many times as you want, and that's the wonderful thing about engineering. Anything else you want me to cover?
How about a round of applause for this guy?
That's it, and if you want to talk more, we'll do Q&A. Thanks so much for coming out. It means a lot to us.
We're going to do a Q&A and keep the mics. We'll just sit down and kind of remember the questions.
Should we take one mic and then we can just pass it back and forth?
Yeah, maybe we should give one mic out. Why don't you,
should we take a seat?
Yeah. So is it okay if we sit down?
I can't see anybody, but I'll see them. Videos. I think we should stand up. Yeah.
Yeah, I've actually seen. I'm falling apart here. Can you
Just put it in your pocket.
take that? I've actually seen some people do some really cool videos where they're doing some crazy transformations, you know, from one style to another. I actually went ahead and created an animation myself just so that I could study the effects of the different deep dream parameters. It's a very simple video, but what I did was I took a single image and I just, for a short few seconds, put up one of the styles, and then I iterated through the different parameter settings, changed to another style, did the same, and you could just see the image changing. If you go to my Dreamscapes gallery, I think you can find that video. It's on Vimeo. But that was really a deep dream parameter study for me. It's fun to share. Some people have done much more fun, interesting, and artistic things with video.
You did the zoom in and out too. The zoom in and out too is interesting.
Yeah, zooming in. Oh, I did. Yeah, one thing you can do with video, of course, is just simply zooming in and zooming out. There's so much resolution in these things compared to even a 4K video that you can zoom in to a factor of 10 and still not have any pixelation. So I did a little music video where I went through all 24 of my first Dreamscapes, and we zoom in nice and slow and dissolve and then zoom out while this song is going on. But you know, my real focus for me is, you know, we're three-dimensional creatures. Even though a lot of you are in tech and we deal a lot in the world of bits, we're still made of atoms, and there's nothing like standing in front of something this big, and that continues to be my focus. I think it's the best way for me to achieve my goal of sharing my experience and giving it to you.
Yeah, that's a good point to remind it. We want to also say a big thank you, and I'm sure you do too, to Wizeline and StartupGDL for putting this together and you know, and buying these large thing of atoms so that you guys can all see it, because even as the people working on this, it was always very frustrating to have to pan and scan and so forth on our computer and try to figure it out, and you never really know if you've achieved that kind of wow moment until you see it in the flesh with that level of detail at that size. And as you saw, even with sort of the best computer technology at these centers, that's a whole room of displays, it's not the same as what that can do in the real world. So I think it's you know, it's only this year that we've had any of these printed, and they've only ever been printed this size at Google, NVIDIA, and now Guadalajara. So I'm really glad you guys got to see it in person.
This is number 7.
Yeah, well, yeah, a couple, that's us. Yeah.
Yes. From the back. From the back. Not me. Well, certainly there are web apps out there that you can run Deep Dream on your own pictures. They're just suitable for smaller pictures. You know. I'm sorry.
I can't, yes.
Yeah.
Teach the photographic style.
Oh yeah, I can certainly teach people how to take the photographs the way I take them. Ultimately, yes. They would have to use the modified version of Deep Dream that these guys worked on, or someone else did something similar, because you won't be able to do that out of the box with Deep Dream.
Yeah. Well, I think it's worth saying too, though, that I think there's so much opportunity for other types of creative expression following this idea of take photo or video and then do some sort of AI-based transformation. I mean, what works about this is that the computer is considering every set of pixels and doing something based on those pixels, right? It's not just a filter you apply to the whole image. But this is one technique with one trained neural net. I'm sure there are tons of other very cool ideas. And so I would actually, and the point is, this stuff is surprisingly accessible. So it's great to use one of these online Deep Dream tools just to play with your own images and get a feeling for what excites you or what you might want to do. But then really it comes time to just, trying to write some code and trying to play with it and see where you get to the point that you're doing something interesting. But we've just scratched the surface, I'm convinced.
I'd like to expand your mind further on that topic, because what this is as a medium is computational photography. This is a phrase maybe you haven't heard, but people are starting to use it. I didn't invent it. Computational photography is creating images using a combination of cameras and computers. And there are so many people doing so many amazingly different things with that combination. This is just one example. It blows my mind, and if you start looking at this stuff up on the internet, Google computational photography and start to look at the kinds of things. Again, we've hardly scratched the surface. There's so much possibility.
These questions are already looking on us as one question for you. So, what would be the next step that you want to go? So now is to create images. What would be the next thing that you would like to go for?
For me as an artist with this?
What's next?
Yeah, that's a good question. So remember how I talked about the far versus near dichotomy, the museum experience? Dichotomy, two things, right? It looks one way from here and a different way from there. When I was at the GPU Technology Conference last April, where these things debuted, I got to meet another deep learning computer graphics researcher working on a different style of dreaming. You maybe heard of deepart.io. A totally different approach, also uses deep learning. And it occurred to me, and we had this long conversation, we're actually working together now to try to create Dreamscapes 2nd edition, where perhaps we do a 3-part experience, where from a distance it looks like a photograph, or maybe not so much, but pretty much still as a photograph. When you get halfway up to it, it looks like a very specific style of, say, Monet's water lilies. Not just Monet, it looks like Monet's water lily style. And then when you get even closer, it's fully dreamed with some crazy details. It's an idea that I think will work. We're working on it. I can't wait to see if it does work. I'm not sure if it will, but that's my next idea.
I just want to be it's very cool. All right, one or two more questions. So, we'll go to the back and we'll take a couple from the front end, and we'll shut this down. Yes, sir.
When you go out and take the pictures, do you go out alone, just by yourself? Because you're talking about connecting with the space, and we want to know if you go alone.
I usually do. My last photo expedition was in a place called Glacier National Park, which has a lot of big grizzly bears, and a couple people have died in and near the park and got mauled in the last few months. So that was a case where I got someone to go with me.
Not me.
we actually had quite a bear scare, but normally the places I'm going to, I don't have that to worry about. I usually, almost all of these I've captured when I was out there by myself. And you know, there is a really nice thing about that experience of, you know, getting in tune with nature and hiking through these places. One thing along the lines of my thesis is what is it about these special places, these specific locations at these specific times that makes this thing happen? And I'm still trying to figure it out. All I know is it happens. When I was walking with my friend in the bear country, we would be hiking for 5 or 6 hours, and you'd be hiking for an hour before all of a sudden it's like, there it is. Do you feel that? And it's not just because the scene opened up and all of a sudden you got a big panorama. It's just everything came together, the light, the composition, everything. And it's like, and it's not just me. I'm like, you know, I'm just more tuned to noticing it. But when I said, there it is, do you feel that? And he's like, yep, okay, I'm gonna set up my tripod and capture it.
Hi.
Yes.
So what requires this technology when you intend to collaborate on a business license or public procurement in the future? And what do you expect from collaborating any of this? What do you expect from the public?
What's the last part? You know.
Yeah, we didn't quite get that last one.
What do you expect from?
What do you expect from if you're going to collaborate any of this in the public? What do you expect from
Oh, if people did it, yeah. So the core Deep Dream stuff is all open source. You can totally go play with that. The modifications we made were sort of custom for this use case, which is not what most people need to do. But like I said, that stuff is available. And in fact, since the stuff that we did, Google has actually open sourced the whole way they do neural nets, this thing called TensorFlow. And they put out a whole series of projects built on top of TensorFlow. And there's even a project, I believe is public now. You know, working at Google, I always forget what's public and not, but I'm pretty sure this is public. But they built this thing called Magenta, which is actually a set of tools specifically for doing creative expression in various forms. And it's not just pictures, it's also for sound and things like that. So there's a whole community of people now working on these tools and how you can run them and play with them and so forth. So I mean, I think that, and they would say the same thing we're doing, which is like, we've had a few of these aha moments that have made us believers that there's something really magical here, but we have no idea what's going to happen, and we just want to kind of put it out there and let people play with it. So we're eagerly part of that community just like everybody else.
What was the second part of that question?
What do you think people will do with the artwork?
Oh, yeah.
Yeah. All right.
Yeah, so AI is starting to be more open to the public. The question is, how do you guys see AI impacting both lifestyle and art in like 10 years from now? What tools / ways of things can we have in our lives on art maybe in 10 years from now?
How is AI going to change art? I'll take a crack at it and then I'll let you have the last word. So, like I said, I'm very excited about it because I think ultimately the way I understand art to work is people have a creative intuition, but there's a lot of editorial as well, right? There's a lot of, like, you know, Edison used to say, if I try 1,000 ideas and I pick one that really works, and you know, the other 999 were just me learning. And I think there's a lot of that in art as well. There's a lot of experimentation and then using your own intuition for sort of what grabs you. Just like you could shoot any scene along that hike and you're picking the one that really works. And so what I think AI will let us do is let us try a much more expansive set of opportunities for what sort of art we want to make. It will do a lot more of the work for us. And again, in ways that, in some ways we have to relinquish control, but we still retain the editorial control, right? The AI is not yet anyway intrinsically motivated to make something for its own purpose. It's going off and you know, working on what you want, but it's doing it in a way that is much more powerful than you can do by yourself. And so, I mean, predicting anything 10 years in the future is very difficult, but I would expect to see a lot more art, composition, video, all kinds of interactive things that are increasingly more made by AIs, but in a way that I think ultimately is pretty amplifying to humans. I mean, I really do see this as one of those areas where it's pretty clear this is a net positive for the humans. In other areas, you know, maybe it's less clear, but I think art is actually a really positive one. And, you know, like, trying to understand what it means to be human, trying to understand the world around us, these are things that the cavemen on have been trying to do, right? It's not like we're going to be solving that problem in the next 10 years, I don't think, right? So if this lets us go deeper, if this lets us have more experiences, if this turns more people onto art, if this makes more people feel like they too can be creative, I think that's a wonderful thing. I think there's tons of room left to have there.
So here's what I'm really excited about the next 10 years or so with this progression. Prior to Deep Dream coming out, as a computational photographer, I was using off-the-shelf commercial software tools, and they were part of my toolkit. You know, artists throughout millennia have used tools to help them create their works. Deep Dream comes along, and it's totally valid to say, oh, Dan just added a fourth piece of software in his software pipeline, in his toolkit. But Deep Dream is so much more powerful and so seemingly intelligent that it truly felt like I was collaborating with an AI, with someone else. And its results really made me start to question reality when it comes right down to it. And as we move into virtual reality, one of the things I'm really excited about is when you get a dreamscape experience that's immersive and it becomes your world, and you perhaps enter a space that feels familiar and it transforms into something totally crazy. It's a wonderful metaphor for reminding people that things are not what they seem. Don't take everything for granted. Keep an open mind. There's a lot more going on than what meets the eye. And that's got to be good for humanity. So that, for me, is what I'm most excited about as we move forward, waking people up.